about it. Hi, I'm Skye.
And I'm DINA.
And we're the Almost Doctors. And this is an OEB Science Cafe short. And today I'm going to be telling you about ants as Legos. Legos! So everybody likes Legos, right? And everybody likes ants.
Obviously.
Right? And so this is actually from this really cool video that I saw online of these ants pulling a worm. And so these ants, there's this really giant worm, which is, obviously weird. And so these ants are really excited about having this giant worm. And so they formed this weird ladder-like structure, and they were pulling the worm into their nest.
Okay.
And I immediately thought, fake.
Gotta be Photoshopped.
It's gotta be Photoshopped. It's not.
It's real.
It's real. And these happen in East Asia, and scientists are baffled. They've never seen ants do this, but they have seen ants do weird stuff. So ants are known to form structures, just like Legos.
Okay.
Okay?
What kind of structures?
Well, they can form things like rafts and bridges and ladders that they can use to climb and escape things. And in fact, one of the most famous examples of this is the fire ant.
Okay.
So fire ants, where they live, sometimes it floods. And when it floods, fire ants die.
Right.
Because they're fire ants, right? They're on fire.
Right.
That's how it works. That's how science works? No, that's not how science works. So these fire ants, what they do is when it floods, the ants actually form a floating raft where the workers are on the bottom and they put the queen and the larva on the top.
Okay. And that sounds like a great thing for the queen and the larvae, but what happened to the ants on the bottom?
Well, it really doesn't matter.
Why?
Well, because they're ants, no. Because the worker ants actually do not reproduce.
Okay.
So only the queen reproduces.
Right.
And so as long as you save the queen and the larva, the genes of the colony move on.
Gotcha.
And we didn't really know how they were able to form these structures. So these bridges and all these kinds of things, they're tough, they're strong, but they're also flexible. And we didn't really understand how that happened. And so David Hu, a researcher, found out how this happens, and it's actually pretty cool. So the way that they do it is they actually form these kind of lattice-like structures. And so the ants will stick out their arms, and they'll stick out your arm, and they'll connect to each other, and they can have up to 20 other ants connecting to their legs at the same time.
Wow.
And it's cool because they don't connect onto the body.
So just the legs.
Just the legs. And the reason they do this is, we'll example here, the reason they do this is that, let's say that we're forming a bridge, right? And we're kind of holding onto it, and all of a sudden we feel some vibration. We can actually tighten up and become more rigid.
Okay.
And support what's happening with the bridge. And if we're floating on the water, we can puff up and form air pockets.
Okay.
And so by pulling ourselves on the legs, we give ourselves the ability to respond immediately to things that are happening in the environment. That's insane!
So cool.
And not only that, but ants come in different shapes and sizes. You may not know this, but they do. And so the way that they do this is they actually organize themselves in a way that makes sense. So the larger ants form these kind of structures, and then the little ants will fill in the pockets.
That's so
They'll
cool.
fill in the holes. I know, it's completely bizarre. And we don't really behaviorally know how this is all happening, right? Because we don't, it's not like someone's like, you, ant number 42, go over there and talk to Bob. It just happens naturally. But what it is cool is it gives us some idea about how we could build robots. So imagine that we could have an army of robots that do the same thing, that connect to each other in the same way and have this flexibility and do these kinds of things. We could have them build all these cool structures, right?
Right.
And we could say, oh, we have a flood,
we need a bridge.
We need a bridge, and then magically there's a bridge.
That's awesome.
How awesome is that?
So what you're telling me is ants are better builders than us.
I'm telling you, ants are better builders than us.
Awesome.
I know! Ants! Right? And so, I personally am very excited about this, and if there are anyone out there from the Department of Defense, or ants,
right?
Anybody who wants to give me money to build robots, please let me know. Please. And so this is Skye.
And DINA.
And we're the Almost Doctors. Go forth and do science.